In this lecture, we solve the differential equation by using removal of first derivative, that is the changing of dependent variable. In the last lecture, we study the second order differential equation and solve the example when one integral is known, that is the first method, and the second method we discuss about the second method. So by removal of first derivative, that is by changing dependent variable y to v, and solve some examples there. So what is the example? So solve dy by dx square minus 2 tan x dy by dx plus 5y is equal to 0 by removal of first derivative or changing the dependent variable. So this is a differential equation. So solve the differential equation by removal of first derivative. So what is the solution? We compare this equation with the standard equation. So what is the standard second order differential equation? dy by dx square plus p dy by dx plus qy is equal to r. So we compare this differential equation with this equation. So we have, what is p? P is this. P is equal to minus 2 tan x. Then q is equal to phi u. And r is equal to 0. Okay. Let us put y is equal to uv. Y is equal to uv. And what is u? Is equal to e raised to minus 1/2 integration of p dx. Minus 1/2 integration of p dx. Okay. So we find when the first derivative remove by substituting this, that is u is equal to e raised to minus 1/2 p dx. So we already discussed about this. What is the u is there? Okay. Then u is equal to e raised to minus 1/2. What is p? What is p? P is what here? Minus 2 tan x dx. So this is equal to e raised to 2 get cancelled, minus plus integration of tan x dx. So what is the integration of tan x? So that is e raised to log of sec x. Because what is the derivative of log of sec x? So that is 1 upon sec x into derivative of sec x tan x. Sec x get cancelled, tan x is remaining there. So derivative of log of sec x is a tan x. So integration of tan x is log of sec x. So this is equal to, so e raised to log of sec x is simply sec x. So we find here u is what? Sec x. With this substitution, which substitution? So that is y is equal to uv. So y is equal to uv is the complete solution. So what is u? U is find here. So that is sec x into v. Okay. So v is to be determined. Okay. So substitute this in this equation. The equation becomes here. With the substitution y is equal to the equation, this is equation 1. Equation 1 becomes d2v by dx square plus q1v is equal to R1. By substitution of y is equal to sec xv, that is uv sec xv, in this equation, the first derivative is removed here. First derivative is removed and the dependent variable y get changed. So we get the dependent variable v here with this substitution. So this equation becomes like that. Okay? Where q1 is what? So we already discussed about this method. So what is q1? So q1 is equal to q minus 1 by 4 p square minus 1 half dp by dx. Okay? So this is equal to, what is q? Q is what here? Q is pi u minus 1 by 4. What is p square? P is this. It's square. P square. P square. So that is 4 tan square x minus 1 half dp by dx. So what is the dp by dx? P is minus 2 tan x. So it's a derivative with respect to x. So minus 2 derivative of tan x is sec square x. Sec square x. Okay? So then, therefore, pi u into 4 get cancelled minus tan square x plus 2 get cancelled minus plus. So this is sec square x. Okay? So this is equal to. What happened here? So this is pi u minus pi u plus, because sec square x minus tan square x is 1. So this is 1. Sec square x minus tan square is 1. So this is 6 here. Okay? So therefore, what is R1? R1 is equal to R upon U. R1 is equal to R upon U. You remember this equation. What is Q1? So you remember also this formula. What is R1? R1 is R upon U. Okay. So what is R? R is 0. So 0 upon U. So that is 0. Therefore, the equation becomes here. What happened? So what is this equation? So this d2v by dx square. Dx square. What is q1? Q1 is 6 plus 6v is equal to, what is R1? R1 is 0. So this is the second order linear differential equation with constant coefficient. Second order linear differential equation is constant coefficient. So this equation can be written by using operator. By using operator, d square plus 6 into v is equal to 0. Okay? So how to solve this differential equation? So the auxiliary equation is what? So this is d square plus 6 is equal to 0. Implies that d square is equal to minus 6. D square is equal to minus 6. So what is minus 6? So this is d square is equal to I square into 6. Okay? Then what are the roots of this equation? So d is equal to, taking square root of this. So this is I root 6 plus or minus I root 6. Okay? So these are the complex roots here. Okay? In the form, so these are the complex roots in the form alpha plus I beta and alpha minus I beta. Okay? So we take many examples of such types, how to find complementary function when the roots are imaginary. So I root 6 minus I root 6 are the two roots, and those roots are complex. Then what is the complementary function? CF complementary function is equal to V is equal to, what is the complementary function? What is e raised to alpha x? So e raised to alpha x into c1 cos beta x plus c2 sin beta x. Okay. So this is a complementary function. Okay. So this equal to v is equal to what? Alpha is what? Alpha is beta is root 6. Alpha is 0 there. Alpha is 0 and beta is root 6. 0 plus I root 6. So alpha is 0. So e raised to 0, that is 1. So that is c1 cos. What is beta? Beta is root 6. Beta is root 6. Root 6x plus what is c2? C2 sin beta. Beta is root 6 x. So this is v. So v is to be determined here. Okay. So therefore the complete solution is so what is the complete solution? So complete solution is y is equal to uv. Y is equal to uv. Okay. So what is u? So u is equal to what? U is equal to sec x. U is equal to sec x. What is v? V is to be determined here. So v is equal to c1 cos root 6x plus c2 sin root 6x. So this is the complete solution of this second order differential equation by solving removal of first derivative. So this is very simple example here. Okay. So now we take another example, very simple example. So take an example. Solve d2y by dx square minus 4x dy by dx plus 4x square minus 3 into y is equal to e raised to x square by removal of first derivative. Removal of first derivative. Okay. What is the solution of this differential equation? So we solve this differential equation by changing dependent variable. Solve. So we compare this differential equation to the equation, standard equation d2y by dx square plus p dy by dx plus qy is equal to r. Where? What is? Compare this. Both equations here. What is p? P is equal to minus 4x. What is q? Q is equal to coefficient of y? 4x square minus 3. And what is r? What is r? R is e raised to x square. Okay. So after comparing both equation we write here. So what is P, Q and R? Let us put y is equal to uv, where u is equal to, you know the formula. So that is the famous formula, e raised to minus 1 half integration of p dx. So this is equal to e raised to minus 1 half. What is p? P is minus 4x. Put a value of p dx. So this is equal to. So minus minus get cancelled. So that is 4 divided by 2. So we get here e raised to integration of 2x dx. So what happened here? So this is what? Integration of 2x. Integration of x is x square by 2. 2 get cancelled. So integration is e raised to x square. E raised to x square. So this is u here. So putting this value with this substitution, so this is equation number 1. With this substitution, where y is equal to uv. So what is u? U is this. Just u is this. E raised to x square into v. With the substitution of y is equal to uv. U is just we obtain e raised to x square v in equation 1. So substitute this value in equation 1, we get the standard equation. So that is d2v by dx square plus q1 v is equal to r1. So after putting this value in this equation, we get this equation. So here the first order, so this is second order. First order derivative is removed here. So where q1 is equal to, what is q1? We know the q1. So that is q minus 1 by 4 p square minus 1 half dp by dx. Okay, 1 half dp by dx. So this is equal to, what is q? Q is this, 4x square minus 3 minus 1 by 4. 1 by 4, what is p? P is what? P is minus 4x. So it's square, p square. So minus 4x square. So that is 16x square. Minus 1 half. What is the dp by dx? dp by dx is what? Derivative of p with respect to x. So that is minus 4. Minus 4. So what happened here? So this is 4x square. So this is also minus 4x square. And what happened here? So this is what? So this is minus 3. And this is minus plus. So this is plus 2. And this is equal to minus 1. So q1 is minus 1. Okay. So what is r1? r1 is equal to r upon u. r1 is equal to r upon u. So what is r? R is this. R is this. So that is e raised to x square divided by. What is u? U is what? U is this. E raised to x square. Get cancelled. So this is 1. Therefore, this equation becomes here d2v by dx square. d2v by dx square. What is q1? q1 is minus v. q1 is minus 1. What is r1? So that is 1. So this equation becomes very simple and we can solve this equation very easily. So that is, after putting the derivative operator, d by dx is equal to capital D, and the 2 by dx square is capital D square. So this equation becomes here d square minus 1 v is equal to 1. So this is the linear differential equation with constant coefficient. We saw many examples of such type. So the auxiliary equation is, what is the next part? Okay, the auxiliary equation. Auxiliary equation of this equation is d square minus 1 d square minus 1 is equal to 0. So this implies that what happened? So this is d square is equal to 1. So what is d? What are the roots of this equation? 1 minus 1. Taking square root of both sides here. So what is the complementary function? CF. CF is equal to, if two roots are different, then what is the complementary function? C1. So this is M1. So this is M2. So what is the complementary function? Y is equal to, just something, that is theory. C1 e raised to M1x plus C2 e raised to M2x. Okay. So this is a complementary function. So what is M1? So what happened here? So that is C1 e raised to M1 is 1. X plus C2 e raised to, what is M2? M2 is minus 1. This is minus 1 minus X. So this is a complementary function. Okay. But now, what is the particular integral? Pi is equal to 1 upon f of d x. So what is this? What is 1 upon f of d? 1 upon f of d is this. D square minus 1. And what is x? This. So this is 1. So this can be written as d square minus 1. D square minus 1. And 1 can be written as e raised to 0 into x. So e raised to 0 into x means e raised to 0, that is 1. So we can write this in this form here, e raised to 0 into x. So this is a very simple one. Okay. So we know how to find the particular integral if f of d. So this is standard formula is equal to what? 1 upon put d is equal to a. So we take many example of such type. Put d is equal to a here. So that is e raised to x. So in this equation, put d is equal to a. Here putting d is equal to a. A is the coefficient of this. So coefficient of x is 0. Put d is equal to a means d is equal to 0. So this is 1 upon 0 minus 1. So into e raised to 0 into x. So e raised to, this is 1. So 1 upon minus 1. So this is minus 1. So this is minus 1. Therefore, the complete solution of this differential equation is, so this differential equation is y is equal to CF plus PI. What is CF? C1 e raised to x plus C2 e raised to minus x plus particular integral. So this is minus 1. This is minus 1. But the complete solution of this differential equation is, complete solution is what? The complete solution is y equal to uv. Okay? What is u? Just u is what? U is this. E raised to x square. What is v? What is v? V is this. C1 e raised to x plus C2 e raised to minus x minus 1. So this is the solution of this differential equation. So the method is very simple, but we remember this equation, also this formula, also this, so we can solve easily. So we taking examples by solving by removal of first derivative method. So then what is the next method to solve such a differential equation, a second order differential equation? And the third method is discussed here. So what is the third method? So change of independent variable. So third method is change of independent variable. So what happened here? So that is, what is it? Independent variable, dependent variable. So that is y is equal to something, y is equal to fx is a primitive, and by using that primitive we obtain the differential equation, second order differential equation, d2y by dx square plus p1 p dy by dx plus qr is equal to r. So this is the second order differential equation. So here we obtain this equation from using this function. So this is a primitive of this differential equation. So y is what here? Y is a dependent variable. Y depends on x, and x is a independent variable. So this is a second order differential equation. First we solve this differential equation when one integral is known. So this is the first method. So then we solve this differential equation by changing dependent variable y to v with particular substitution. So this is second method. And what is the third method? Third method, so x is independent variable. We change here the independent variable x to v with particular substitution and solve this equation. So this method we'll discuss in the next lecture. So we stop here. Thank you.